So this eclipse is going to start out over the Pacific Ocean. It's going to hit land first in Mexico, enter the U.S. through Texas, and then head towards Indiana and head out to the Atlantic Ocean via Canada. Looking at a more detailed view of the U.S., the blue line here, this will be the center of the path of the total eclipse, while the red lines will be the very edge. So notice how Dallas is going to see it, but Houston, Texas, it's going to miss it. Little Rock, Arkansas will just make it, but Memphis, Tennessee, that's out. St. Louis, Chicago, Louisville, Cincinnati, Columbus, Ohio, Detroit, they're all going to miss totality, but not Indianapolis. So this is going to be huge, and expect there's going to be lots of people coming to Indianapolis for this event. This is Holcomb Observatory right in the heart of Butler University, and it's going to be a free eclipse viewing experience there. All the times that I'm going to be talking about in this video are going to be based off of Butler University's timing, because it's going to be a really cool place to come and witness it with a lot of people, and a lot of people who know a lot about the eclipse. We're going to have a number of telescopes out, all equipped with solar filters so that we can safely look at the eclipse during the partial phases. There will be food trucks, there's going to be music, there's going to be free parking available, so it'll be a really cool event to experience at Butler. So there are three basic types of lunar eclipses. Penumbral, where the moon will only slightly darken. Partial, where some of the moon's shadow will cover the moon. And finally, a total lunar eclipse where the full moon will be completely within the Earth's shadow and may even take on a reddish tint from all of the red light from sunsets all around the world. On average, these different eclipses may be seen every 1.5 years if you're a penumbral eclipse, every 2 years if you're a partial eclipse, or every 2.25 years if you're a total eclipse. Solar eclipses actually happen just slightly under every 6 months on Earth. Here you can see that the eclipses actually always come at least in pairs, alternating between lunar and solar, or solar and lunar. So every calendar year is guaranteed at least 4 eclipses. And total solar eclipses happen on average every 2 years somewhere on the Earth. Here you can see all of the total solar eclipses that have happened or will happen throughout the 21st century. But notice how much happens over the oceans and how unlikely it is for one spot to get a total eclipse. So the place that you live, you might only get a total solar eclipse once every 375 years. So this isn't just a once in a lifetime event, it's a once in many lifetimes event. In fact, Indiana hasn't had a total solar eclipse since 1869, 155 years ago. That was only visible for the southern part of the state. Indianapolis hasn't seen a total eclipse since 1205, a mere 819 years ago. And Butler University hasn't had one since the year 831, nearly 1,200 years ago. So this is going to be a really big deal for the city. So what's happening during a total solar eclipse anyway? Well, if the moon is exactly in between the sun and the Earth, the moon will block the sunlight and cast its shadow on our planet. That dark path of totality basically shows the moon's motion through its orbit around the planet. If you're outside of the path, you'll see a partial eclipse, but you won't experience the total eclipse, as you'll always see at least part of the sun. And the further you get away from the path, the less the sun will be eclipsed and the harder it will be to notice anything. And if that doesn't look like the moon sitting between the sun and the Earth, well, that's actually just the far side of the moon that we can't ever see here from our planet. It'll be daytime on that side of the moon, which is why we can't see the moon during the eclipse, only its shadow. So hopefully everybody knows that you should never ever stare at the sun. Only when the sun is completely blocked by the moon can you safely look in the direction of the sun. During the partial phases, you'll always want to protect your eyes with eclipse glasses, or also known as solar viewing glasses. Make sure you buy from reputable vendors. They must meet ISO requirement 12312-2, the standard for safe solar viewing. This means they must block 99.999% of all visible light. which means that you should only be able to see very bright light sources through the glasses. They also have to block 100% of UV and infrared light. While your eyes can't see these forms of light, the sun is still shining powerfully in these invisible areas. That's why it's also important to not use glasses over 3 years old, such as from the 2017 eclipse. You wouldn't even notice these types of light coming in, make it all the more likely to damage your eyeballs if that's making it through the glasses. Definitely do not use sunglasses or anything you make of your own to try to stare at the sun. Just don't risk it. So, first contact is the start of the partial eclipse. At Butler, this is going to begin around 1:50 p.m. You won't likely notice it at first, but you'll slowly start to realize that there's a small bite seemingly taken out of the disk of the sun as the partial phase continues and the moon starts to cover more of the sun's disk. One thing I want to clear up is that it's perfectly safe to be outside during an eclipse. The reason why you hear so much talk about never staring at the sun as it relates to eclipses is simply because people now have an incentive to look at the sun. Normally, the bright light hurts your eyes so much that people are going to look away, but it's not every day that the moon starts to block some of the sun, so people are naturally curious during an eclipse. Just make sure to always protect your eyes during the partial phases. Even as it starts to get noticeably darker as totality approaches, it's important to realize that a 90% eclipsed sun is still 100,000 times brighter than totality, so this will really damage your eyes if you're staring at it. Only during totality can you safely look at the sun without protection, and we're definitely not there yet. About 40 minutes before totality begins, you'll likely start to notice partial eclipse shadows. If you look at the little bits of sunlight coming through the shadows of leaves on a tree, the crescent shape of the partial eclipse will actually become noticeable on the ground. This is probably going to be easier to see if you're looking at a nice smooth surface like pavement, and definitely a little bit tougher if you're looking at the grass. But you can even use your hands with your fingers interlocking or even a colander to see this same basic effect. And as totality starts to get even closer and it starts to get noticeably darker, you should definitely expect temperatures to drop as the moon's full shadow approaches you at 2,100 miles per hour. These changing temperatures mean that the winds will likely start to shift the direction they're coming from. You may even notice that birds and other animals likely think that nighttime is coming, and so are going to try to start roosting and start going to sleep. With only about 1 minute until totality, you may start to notice shadow bands. But because these can be hard to see and we do not want to miss totality, we're going to wait until after totality to look for these. With just about 10 seconds left until totality, you should start to notice the diamond ring effect. This is basically the very last bit of remaining sunlight trying to shine through before you are totally within the moon's full shadow. Give it a few seconds to be safe, but once the diamond ring effect disappears fully, you are in totality. You can take off the solar eclipse glasses and enjoy. Just after 3:06 p.m. Butler time is second contact, when no part of the sun's bright disk is now visible. It's completely disappeared. You should be able to easily see the sun's corona. Corona just means crown, and this is the sun's outer atmosphere extending out into space around the sun. You may even be able to see these very small reddish colored solar prominences, which are just caused by super hot hydrogen gas around the sun. During totality, if you look around, you should start to notice a few other bright points of light start to appear in the darkened sky. You should definitely be able to see Jupiter to the left of the sun, Venus over to the right. You may even be able to see Saturn and Mars even further to the right, but still lined up with the sun and the other planets. Far off to the west near the horizon, you may be able to see Sirius. Up above that, you may see some of the stars from the constellation Orion. Betelgeuse in the upper left corner, Rigel in the lower right corner are going to be a couple of the brightest objects. High up above overhead, you may be able to see the bright star Capella. But it's also important to remember that the sun is actually still shining about 50 to 60 miles away from you, so off in any direction towards the horizon, you'll likely see the glow of something looking a lot like a sunset. Take it all in and enjoy totality for 3 minutes and 42 seconds. Because just before 3:10 p.m. Butler time comes third contact, and totality is over, and you're going to have to put your solar eclipse glasses back on. As soon as you start to notice the diamond ring effect again, it's no longer safe to stare at the sun. And because your eyes were enjoying nearly 4 minutes of darkness, the returning sunlight is going to pack even more of a punch. Even a 99% eclipse sun is 0% totality and not safe to stare at. But now is the time to start looking for shadow bands. These are caused by turbulent rising air masses in the dimming light, the same reason why stars may appear to twinkle at night. They'll look something like shadowy snakes quickly moving across the ground. Again, these can be hard to notice, but easier if you're looking at a smooth, light-colored surface. But before long, they'll become unnoticeable in the quickly brightening skies. And then fourth contact will come around 4:23 p.m. when the eclipse officially ends, but let's be honest, most people have already packed up and headed home as the main show's already over. So when might you see the next total solar eclipse? Well, you may see just a little bit of one in 2044 if you live in Montana or North Dakota. Otherwise, you're going to have to wait until 2045 for one that'll come across most of the US. But unfortunately, it's going to miss Indiana. So just wait a little bit longer, and Indy will have another one in 2153. One final note, what kind of weather might we expect to have that day? Well, this map basically shows what fraction of the sky different areas have had over the last 30 years, and April can definitely have its fair share of cloudy weather here in Indiana. But as this animation shows, it really can vary a lot from year to year. Even if we have mostly just the high, wispy cirrus clouds, you should probably get a pretty good view of the eclipse. But if we have an overcast day, it's not going to be good. Either way, it will be dark in Indy just after 3 p.m. that day. Wherever you choose to go that day, there are some great online resources for finding the exact timing of the eclipse anywhere in the US. This eclipse simulator can show you what to expect and when to expect totality. And the folks at Butler University and the American Astronomical Society have put together some really good resources for what sort of protection can keep eyeballs safe during the eclipse. So wherever you go, just make sure to get into the path of totality, or you're going to have to wait a very long time until the next one.